We proceed to our discussion section, and let me see. There is a number of questions for Fred. Let's begin with a question by Kumpeng Yao, who has a question concerning the first part of your talk, asking whether in the bimanual coordination, the frequency ratio between the two hands plays into it and enhances the bimanual capabilities.
So in the first experiment, the bimanual one, the frequency content was the same for the right and the left hand. Okay, and actually we didn't look for different frequency ratios. It looked like people were doing the same movement anyway on both hands. So whatever was doing the target, the hand motions were the same on both hands. So I believe, although I did not understand this question, but otherwise the frequency content was the same for each hand. Except maybe one thing, if you look at the unimanual tracking task, where you'll see that the frequency content is the same for the right hand, except that in terms of tracking error, the frequency content of the tracking error is just smaller in size. So there is no like special frequency making the right hand better than the left hand in terms of tracking error. There's just a gain factor between the two.
Okay, so thank you. Let's move to Andreas' questions, who asked whether the gain in the decomposition experiment was only transient, and what degree, right, there is persistence of the patterns you see.
So true. If there is any gain, it's easier to see during the composition than during the decomposition. So when you look for the gain for decomposition, yes, it's only during the very first trial that you see an advantage of prior experience. Still, now you may look at transfer in different ways. Some people focus on the very first trials. Some people may average these benefits across all the successive trials. What is obvious here is that there is still a benefit for both composition and decomposition of prior experience, but true effect is more obvious during the composition.
Maybe with these two questions, let's switch over to Oliver to mix up a little bit. And there is a question and comment by Cosimo della Santina, who is firstly giving you lots of compliments. Amazing, congratulations. He loves your hand. And then says, I may have missed that how many independent degrees of actuation does the hand have? And is there a bare minimum to get to the level of dexterity that you are showing?
So the hand has 16 independently actuated degrees of freedom. There are 2 in each finger. There are between, there are 3 between the fingers. There's 1 to oppose the palm. There's 3 to place the thumb and 1 to bend the thumb. I hope that adds up to 16. If not, I missed one. It's a good question to wonder what sort of a minimum number of degrees of freedom is to make a really dexterous hand. I think this will clearly depend on the particular thing that you want to solve. So our attempt was to come up with something that is a compromise between being able to service a bunch of different research projects, while at the same time having a manageable complexity. But we will find out if we need to add degrees of freedom or not to the hand. And one of the advantages is that this hand is very modular and can be extended. So if we discover that we need more degrees of freedom, we will just add them to the hand. But I don't know if there's a minimum number. No idea.
Let me follow up with another question, says Kevin. What do you think are some general principles for designing such funnels?
Well, this is the key question, right? This is the million-dollar question. Basically, this is what the research program really is about. One of the principles so far has been that we exploit geometry in the environment. And this is easy, right? I mean, this is kind of obvious. I think this is common knowledge in robotics that a table surface actually helps you to do grasping. But we've discovered that there are really kind of interesting and intricate other ways of discovering funnels. So for example, if you grasp something from a pile of homogeneous objects, then just sinking your hands into the pile actually results in a physics process of the interactions between all the different objects that ultimately ends up pushing, singulating an object into your hand. So there seems to be a funnel that results from the interactions of different objects in a pile. And right now, with what I showed you, I guess that kind of is the start of trying to explore funnels and understand the principles of finding and using funnels that are generated within an anthropomorphic hand. And the things that I've shown to you are basically where we stand right now, as of yesterday. But the goal will be to identify exactly such principles so that we can generalize and also guide hand design using those.
Just may I intercept and say that it would be possible if there is another response to your response to sort of get more into a back and forth by raising hands. But as there is none right now, I will switch over to another question.
There is one. I think Reza raised his hand.
Ah, okay. Reza?
Yeah, I had a question for Frederic. In the most basic way of this tracking, single hand tracking, just a cursor, what is the limit of how fast this object can track? Is there a certain bandwidth in human tracking controller?
So what we did not explore all the possible trajectories. I believe there are many factors that may limit tracking performance. One of them is target motion complexity, target speed as well. And so this is really a multidimensional problem. So far, what we decided is for all the patterns that we employed, they all resulted from the combination of two sinusoids along the horizontal and the vertical axis. And still, we made sure that the mean tangential velocity was the same for all those target patterns. So really, I feel like it's really an open question now to assess how those results extend to different pattern trajectories, because frankly, there are really many ways to change those trajectories. Maybe one thing we also did was also to compare whether there was also an effect of target complexity if you investigate the approximate entropy of those trajectories. Okay. Well, it was not that clear that maybe we didn't use such a large set of patterns to find those differences, but it looked like at that level, approximate entropy was not necessarily the best variable to assess tracking performance in terms of separating those pattern trajectories.
Okay, maybe I will raise one more question from the chat line by Bob Scheid, who asked about how much prior experience your subjects had with such bimanual tasks and whether the inability to perform optimally is due to insufficient learning in the novel task. And let me also add, this reminds me of some interesting, very recent work in primate neural recordings where it has been shown by the group by Batista that certain tasks then actually take like a magnitude longer to learn, but they can be learned. So is there a learning rate given certain challenges?
So obviously, there is always an issue of learning in all these protocols. So we decided to give 40 trials of practice for each bimanual mapping. So given that each trial was 10 seconds long, so each subject received 6 minutes of practice for each mapping. And what you can see is that even though people are getting better and better at doing those tasks, so meaning that the cursor target distance decreases across trials, they still keep on making similar hand movement in space. So really this fact that there is a strong tendency in making similar hand movement in space doesn't change those 43 hours, even though subjects are making progress in minimizing the cursor target distance. And now I would like also to add for the minimization of efforts. So with the split mapping, we actually try to prime the good solution for the subjects. So we give them some practice with restrained joystick. So joystick that could not move along 2 dimensions. So really they were constrained on making fractionates and movements. Okay, so people are having initially a hard time performing the task with guiding rails, but ultimately at some point they are doing a reasonable job. But as soon as you release the rails on the joystick, people are doing again similar hand movement in space. So even if you prime the good solution, it still doesn't work. People are getting back to doing similar hand movement in space.
Okay, thank you, Fred and Oliver, for the additional explanations.